Welcome to our mathematics class. The topic for consideration today is Introduction to Trigonometric Reciprocals. By definition, the reciprocal of a number is 1 divided by that number. Let us look at an example. The reciprocal of 5 is 1 over 5. The reciprocal of 9 over 5, it's 5 over 9. How do you get to that? By definition, reciprocal of a number is 1 divided by that number. So the reciprocal of 9 over 5 would be 1 divided by 9 over 5. Now this takes us to our knowledge of fractions. We would make 1 to become 1 over 1, and that would give us 1 over 1 divided by 9 over 5. From our knowledge of fractions, we also know that if we have a division sign, we will convert it to a multiplication sign, and that would change the number on the right to be the fraction on the right to have its denominator become a numerator and its numerator become a denominator, and that would yield 1 over 1 times 5 over 9, and multiplying the numerator by numerator, we would get 1 times 5, which is 5, and multiplying the denominator by denominator, it would give us 1 times 9, which is 9. So finally, our answer is 9 over 5. So this confirms that the reciprocal of 9 over 5 is 5 over 9. Example 3, in the same manner, the reciprocal of 2 over 3 is 3 over 2. In the same manner, the reciprocal of 1 over 6 would be 6 over 1, which is 6. Now let us consider the properties of reciprocals. The product of two numbers that are reciprocals is always 1. Example, let us look at the number 9 over 5 and the number 5 over 9, which are reciprocals. If we multiply them, we would get 45 over 45, which confirms that the product of two reciprocals is 1. Now let us focus on trigonometric reciprocals. Given the diagram or given the triangle, and our focus is on angle alpha, let us look at sine alpha. Sine alpha is the opposite over hypotenuse, which means sine alpha is equals to AB divided by OA. And if we are to find the reciprocal of sine alpha, it will be 1 divided by sine alpha. And we know that sine alpha is AB over OA. That would give us 1 over 1 divided by AB over OA, which takes us to fractions again. And then we would convert the division sign into multiplication, and that would make the numerator of the fraction on the right to become the denominator, and the denominator to become the numerator, and that yields now OA over AB. So in short, the reciprocal of sine alpha is OA over AB. And what is OA? OA is the hypotenuse, and AB is the opposite side. And what we know, it's the hypotenuse over the opposite side of angle alpha is cosec alpha, and therefore this concludes that the reciprocal of sine alpha is cosec alpha. Let us look at the next example with the triangle AOB, and our focus being on angle alpha. Cos alpha is adjacent over hypotenuse, which is OB over OA. Now, what is the reciprocal of cos alpha? As according to the definition, it will be 1 divided by cos alpha. That gives us, back to our knowledge of fractions, 1 would become 1 over 1, and cos alpha as defined is OB over OA. We would convert the division sign into multiplication, and that would yield OA over OB on the right fraction. And finally, our answer is OA over OB. And OA is our hypotenuse, OB is the adjacent side, and that says to us that the reciprocal of cos alpha is sec alpha, and going forward we will know every time we are required to state the reciprocal of cos alpha, we would mention it as sec alpha. And there's an exercise for us to find the reciprocal of tan alpha, to show that the reciprocal of tan alpha is cot alpha, to show that the reciprocal of sec alpha is cos alpha, and to show that the reciprocal of cosec alpha is sine alpha. The properties of reciprocals, we know that two numbers which are reciprocals, if they are multiplied, the answer or the product will always be 1. Let us put that to a test with trigonometric functions. Then let's multiply sine alpha by cosec alpha. We know that sine alpha is opposite of hypotenuse and cosec alpha is hypotenuse over opposite. Then from the given triangle, we see that the opposite value is 8 and the hypotenuse is 10. When we substitute the values, the sine alpha would become 8 over 10 and cosec alpha would become 10 over 8, and that yields 80 over 80, and that's a 1. In that case, we can confirm that sine alpha and cosec alpha are reciprocals because their product yields 1. And there's an exercise for you to now show us that the product of tan alpha and cot alpha, which are reciprocal, would give us 1, and to show that the product of sec alpha and cos alpha would yield 1 as they are reciprocals. Looking forward to seeing you in the next lesson. Thank you very much for joining us.